Hi, I'm Randall Heyman, a mathematics academic. The coronavirus outbreak is affecting almost everybody in the world, so I'm using my YouTube channel to help university educators, high school teachers, students and parents with any mathematical problems and concepts that they're having. So if you'd like me to make a video for you or your students, use the comment section below the video. So we're currently working towards understanding these ideas here for a class in California. So I wanted to talk about, well, I've done a video on referring you to my YouTube video, Mathematical Groups Made Easy. There's a couple of points I need to make on groups before we head off. Then we've got a basis to talk about rings and fields and whatever. So the first thing is 3 points I just want to make in this video. First is, you'll hear talk of abelian groups. Maybe I should spell that correctly, or write it clearly. Abelian, named after a mathematician, Abel. And it just means that the group is commutative. And what does commutative mean? Well, let's take the case of this ring. So it's the integers and the operation is addition. So all that means is that it recognizes that we know from primary school that 1 plus 7 is the same as 7 plus 1. So it just means you can change the order of the operation. That's what commutative means, and that's what abelian means. So you'll hear me later talk about abelian groups. That's all it means. Okay, the second thing is that you can have finite groups. In other words, you can have a group that's only got a finite number of elements in the set. So here's an example of one. I'm going to use 0, 1, 2. That's a set. And the operation will be addition. But what we put here is where addition is carried out modulo 3. So modulo 3 is talking about modular arithmetic. If you're not sure about modular arithmetic, have a look at my video, Modular Arithmetic Made Easy, but you don't really need to know it for the point, for what we're doing, I don't think. So this is a perfectly valid group. In particular, it is closed under addition, because if we go 2 plus 2, remember the addition is modulo 3, which means that we don't write 4, we write the remainder when we divide by this 3 here. So 4 divided by 3, well, 4 equals 1 times 3 plus 1. So the remainder is 1. So we would just write 1. And you can see here that 1 is actually in the group. So that's a perfectly valid group. And then the third thing I wanted to talk about is that closure. Now, I put in the definition of group a specific requirement that we have closure under addition. If I was actually going to define addition properly, say for this one up here, let's talk about this one here. What I would actually say, I wouldn't just put plus. What I'd do is I'd write properly what addition is. And addition is actually a mapping. So addition, it's a mapping from, I take the integers, and what we put here is the direct product z times z, and it maps it to z. So just like you've probably seen with functions, to do them precisely, you've got to put the domain and the codomain. In this case, if you're actually specifying the addition or whatever this operation is properly, you would actually write it like you would add this sort of idea to the definition. And this, of course, ensures that we have closure, because we're saying here that the mapping actually does map to the integers. So we have closure there. Now, with groups, I specifically mentioned it. If you look up, I'm going to in the next video launch into rings. If you look up the definition of rings on the internet, you'll see in a lot of cases they don't mention closure. And that's because it's implied in the proper understanding and proper definition of the operations that are involved with rings. Okay, so that's all I wanted to say now about groups. Next video we launch into rings. If you've got any more questions about groups, please ask, or anything else in mathematics. Doesn't have to be at university level. I'm happy to go to high school level, and I'll even go down to primary school level. I think I can remember most of that. So please don't hesitate to ask me any question on any aspect of mathematics. If I don't think I can answer it, I'll tell you. Thanks very much.